Hello friend, welcome back to our new video. Today we discuss on the topic of Ohm's law. Ohm's law states the relationship between electric current and potential difference. The current that flows through most conductor is directly proportional to the voltage applied to it. George Simon Ohms, a German physicist, was the first to verify Ohm's law experimentally. Tables of contents. Ohm's law explanation. Relationship between voltage, current and resistance. Water pipe analogy for Ohm's law. Experimental verification of Ohm's law. Ohm's law magic triangle. Ohm's law solved problem. Calculating electrical power using Ohm's law. Formula to find power. What is a power triangle? Ohm's law pie chart. Ohm's law matrix table. Ohm's law application. Limitations of Ohm's law. Frequently asked question. Ohm's law explanation. One of the most basic and important laws of electric circuit is Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. Mathematically, this current minus voltage relationship is written as V equal to IR. In the equation, the constant of proportionality R is called resistance and has units of ohms with the symbols column. The same formula can be rewritten in order to calculate the current and resistance respectively as follows: I equal to V over R equal to V over I. Ohm's law only holds true if the provided temperature and the other physical factors remains constant. In certain components, increasing the current raises the temperature. An example of this is the filament of a light bulb, in which the temperature rises as the current is increased. In this case, Ohm's law cannot be applied. The light bulb filament violates Ohm's law. Ohm's law statement. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. Ohm's law equation. V equal to IR, where V is the voltage across the conductor, I is the current flowing through the conductor, and R is the resistance provided by the conductor to the flow of current. Relationship between voltage, current and resistance. Current diagram: battery voltage, total resistance and current. 3 volt, 6 column, 0.5 A ampere. Second circuit diagram: 6 volt battery voltage, total resistance 6 columns or current 1 ampere. Third circuit diagram: 9 volt battery, 6 columns resistance and 1.5 ampere current. Analyzing rows 1, 2 and 3, we come to understood that doubling and tripling the voltage leads to doubling and tripling of the current in the circuit. Likewise, when we compare rows 1 and 4 and rows 2 and 5, we come to understand that doubling the total resistance server to half the current in the circuit. Water pipe analogy for Ohm's law. Ohm's law describes the current flow through a resistance when different electric potential voltages are applied at each end of the resistance. Since we cannot see electrons, the water pipe analogy helps us understand the electric circuits better. Water flowing through pipes is a good mechanical system that is analogous to an electrical circuit. Here the voltage is analogous to water pressure, the current in the amount of water flowing through the pipe. And the resistance is the size of the pipe. More water will flow through the pipe current when more pressure is applied. Voltage at the bigger pipe lower the resistance. Experimental verifications of Ohm law. Ohm's law can be easily verified by the following experiment. Apparatus required: a resistor, ammeter, voltmeter, battery, plug key, rheostat. Procedure: initially the key K is closed and the rheostat is adjusted to get the minimum reading in ampere A and voltmeter V. Point number 2. The current in the circuit is increased gradually by moving the sliding terminal of the rheostat. During the process, the current flowing in the circuit and the corresponding value of potential difference across the resistance wire R are recorded. Third, this way different sets of value of voltage and current are obtained. Fourth, for each set of values of V and I, the ratio of V over I is calculated. When you calculate the ratio V over I for each case, you will come to notice that it is almost the same. So V over I is equal to R, which is a constant. 6. Play a graph of the current against the potential difference. It will be a straight line. This shows that the current is proportional to the potential difference. Similar readings: Kirchhoff's law, Faraday's law, law of thermodynamics. Ohm's law magic triangles. You can make use of Ohm's law magic triangles to remember the different requirement equations for Ohm's law used to solve for different variables. If the value of voltage is asked and the value of the current and resistance are given, then to calculate voltage simply cover V at the top, so we are left with the I and R, or I cross R. So the equation for voltage is current multiplied by resistance. Examples of how the magic triangle is employed to determine the voltage using Ohm's law are given below. Ohm's law solved problems. Example 1. If the resistance of an electric iron is 50 coulomb and a current of 3.2 ampere flows through the resistance, find the voltage between 2 points. Solution. If we are asked to calculate the value of voltage with the value of current and resistance, then cover V in the triangle. Now we are left with I and R, or more precisely I cross R. Therefore, we use the following formula to calculate the value of V. V equal to I cross R. Substituting the value in the equation, we get V equal to 3.2 ampere cross 50 coulombs equal to 160 volt. So V is equal to 160 volt. Example 2. An EMF source of 8.0 volt is connected to a purely resistive electrical appliance. An electric current of 2 ampere flows through it. Consider the connecting wire to be resistance-free. Calculate the resistance offered by the electrical appliance. Solution. When we are asked to determine the value of resistance when the value of voltage and current are given, we cover R in the triangle. This leaves us with only V and I, more precisely V section divided by. Substituting the value in the equation, we get R equal to V divide I. R is equal to 8 volt divide 2 ampere equal to 2 coulomb. So resistance is equal to 4 coulomb. Calculating electrical power using the Ohm law. The rate at which energy is converted from the electrical energy of a moving charge to some other form of energy, like mechanical energy, heat energy, energy stored in magnetic field of electrical field, is known as electrical power. The unit of power is watt. The electrical power can be calculated using Ohm's law and substituting the value of voltage, current, and resistance formula to find power. P is equal to Vi when the value of our voltage and resistance are given. P is equal to V square divide R when the value of our current and resistance are given. So P is equal to I square R.